Welcome to another session of energy storage devices. There are many types of energy storage devices. Today we'll understand just about batteries, and especially we are going to concentrate on dry cell, which is also called as Leclanche cell. Before we move on, subscribe if you haven't subscribed yet for watching such informative videos, and tap the like button if you like the video and share the video with your friends. First, before moving into batteries, let us understand what is an electrochemical cell and electrolytic cell. In an electrochemical cell, the chemicals present inside the battery undergoes a chemical reaction to produce energy. That is, when we are using the battery, the chemicals present in the battery will be undergoing a chemical reaction to produce electricity. So, we can say that chemical energy is getting converted to electrical energy when we are using the battery, that is during discharging cycle. And electrolytic cell, that is if you are having rechargeable batteries, when the battery gets discharged and we charge it back, the same chemical reactions can be reversed back by passing electricity inside the battery during charging cycle. So we can say that electrical energy is getting converted to chemical energy. That is, in a battery, when we are using the battery, we call it as discharging cycle and it acts as an electrochemical cell. During charging cycle, it acts as an electrolytic cell. Now let us move on to the classification of batteries. Primary batteries are the batteries where the chemicals present inside the battery undergoes chemical reaction to produce electricity. And once the reactants get over, we call that battery to be exhausted or dead and we throw off the battery. That is, we cannot recharge the battery. These are called as primary batteries. So, it acts only as an electrochemical cell and it does not act as an electrolytic cell because we cannot charge them. The examples are dry cell and alkaline cell. Secondary battery. It is a rechargeable battery which can be charged and discharged for many cycles. That is, the reactions which took place during discharging cycle when it is acting as an electrochemical cell, these reactions can be reversed by passing electricity in the opposite direction. So, it acts both as an electrochemical cell during discharging cycle and electrolytic cell during charging cycle. Examples are nickel-cadmium battery and lead-acid battery. Lastly comes the flow battery. Here, the chemicals or the reactants involved in the reaction flows through the cell to produce electricity. That is, as long as we supply these reactants, we get electricity. Once we stop the supply, we will not be getting electricity. The best example is the fuel cell. Let us look into the construction of the dry cell, which is also called as the Leclanche cell. These are the dry cells. Here the brand is Nippo. You can get in various brands. If you actually remove off the plastic cover, that is this ad, you will see a grey container which is made of zinc. This is what you will be seeing. Further, if you break open the battery, you will see that there is a black rod inside which is made of carbon or graphite rod, which acts as the cathode, and the zinc container acts as the anode. That is, the whole container is acting as the anode. And to hold this carbon rod, we just have a clip. And we need to have an electrolyte. Here the electrolyte is a mixture of MnO2, NH4Cl and ZnCl2. All these are mixed. In order to form a mixture, proper mixture, we use little starch and little water to make it as a paste, and it is filled inside the battery. The electrolyte is filled inside the battery. We should understand that this electrolyte is acidic in nature mainly because of the presence of NH4Cl. And the top edge, that is the metal cap edge, is the positive end and the bottom one is the negative end. That is, the anode is a zinc container, cathode is the graphite or carbon rod, electrolyte is a mixture of MnO2, NH4Cl and ZnCl2. And the voltage what we get from these batteries is 1.5 volts irrespective of the size. That is, you can see that the various sizes are available, but the voltage will be 1.5 volts, but the amperage, that is your current which we get from these batteries will be differing. That is, the bigger the size, will be getting more current. So, depending on the application, we need to select the size of the battery. Now, we will look into the redox reactions. We should understand that always at anode oxidation occurs. Oxidation means the metal will form metal ions to release electrons. That is, here my anode is zinc container. So zinc will be oxidized to form zinc 2 plus to release 2 electrons. And usually the cathodic reaction, the cathode as such will not take part in the reaction. The electrolyte will be taking part in the reaction. Here the major electrolyte is MnO2. So MnO2, and the water we are getting it from the starch, that is in the mixture itself we will have some water. And the electrons which is released at the anode is gained by this MnO2 to get reduced to form Mn2O3, which is manganese oxide, and it forms 2 OH minus ions. Here one important thing is, we all know that manganese is a transition metal, and transition metals are present in various oxidation states. So MnO2 not only forms Mn2O3, it can form various types of manganese oxide. So although for simplicity we are representing this one single reaction, actually we can have many parallel reactions where different types of manganese oxides can form. So it is a complex reaction. Next, here OH minus, we know that it is basic in nature. So the NH4 plus, which is present in NH4Cl, this NH4 plus reacts with OH minus to undergo acid-base neutralization reaction to produce ammonia gas plus water. Here this is the most important part. It is gaseous in nature. As the reaction takes place inside the battery, which is enclosed and it's a closed chamber, if the gas is released, it will be disrupting the flow of electrons. So this oxidation and reduction reaction itself will not take place properly, and the efficiency of the battery will be reduced. So in order to avoid that only, we are using zinc chloride. So the zinc chloride will take up this ammonia gas to form a complex, and this complex is solid in nature. So where this forms is around the electrodes, that is anode and the cathode, especially cathode is in the center, so around it this product will be formed. So what this is going to do, we'll be seeing in the next slide. So due to this, we have limitations of this battery or disadvantages of using this battery. That is, when current is withdrawn rapidly from it, very important, rapidly from it, the voltage drops, since the products build up on the electrodes. That is why I said this complex, zinc complex, which is formed, is a solid in nature, and it occupies around the electrode, and this slowly affects the voltage, especially when the current is withdrawn rapidly. That is why we are not supposed to utilize these cells where more current is required. And another major drawback is the electrolyte, as I said already, is acidic in nature. So the zinc metal, that is the container itself, can dissolve and undergo corrosion. That is why when we are not using the battery, we are supposed to remove the battery from the gadget. And if you look at the applications, it can be used in clocks, remote controls, toys, calculators, torchlights. And in those days, they were using in transistors and radios. And now we know that these are outdated. Here, that is why I said, now if you are using it in a clock and remote control, especially in TV remote control and all, a single battery itself, single cell itself will work for nearly 6 months to 1 year. So it's very, very apt in using for such applications. Toys, if it's a very small toy where the current consumption is very less, you can very well use it. But if it's a remote car where more current is going to be utilized, it's better to avoid such type of batteries. Calculators generally do not consume much of current, so you can use these places. Now you should understand why I am very often changing the word cell and battery. Actually, a single battery, a unit cell, we call it as a cell only. That is, one combination of this, we call it as a cell. But when many cells are placed in a series, we call it as a battery. So in a torchlight, if I am going to use 2 cells, I call it as a battery. Normally, if you have a unit cell, we call it as a cell. But in common use, we use the word battery as well as cell put together. Please do subscribe if you haven't subscribed yet, and share this video with your friends if you like it. And that's all for the session. Thank you.